Okay, today we're going to be talking about square roots and using the actual square root functions to solve quadratics. Some quadratic equations end up with square roots as a solution. When you solve an equation by taking the square root of both sides, you get two solutions, the positive and negative roots. So let's solve the following. X squared plus 2 equals 11. So how would I solve this algebraically? I'd move the 2 over by subtracting 2. So then we get x squared equals 9. And a lot of people will go directly to square rooting and just get 3. But the habit to get into is when we square root, we need to have the positive and the negative roots of it. So let's check our answers. If I put 3 in for the x, I get 3 squared plus 2, which is 9 plus 2 is 11. If I put negative 3 in for the x, I'm taking negative 3 and I'm squaring it, which means negative 3 times negative 3, which is positive 9. And then if I add 2, I get 11. So do you see you get two answers? Okay, so next one. Move the 2 over, we get 3x squared equals 15. Divide by 3, we get x squared equals 5. And in this case, 5 is not a perfect square, so we're going to leave it as a root. So x equals plus or minus the square root of 5. Does everybody see that I'm square rooting both sides to get the answer? The square root of x squared is x, the square root is 5 is plus or minus the square root of 5. Leave answers with radicals when they are not perfect square. Don't use your calculator. This is considered an exact answer. When you go on your calculator and get the square root of 5 and you get a decimal of 2.23606, it's an irrational number. It goes on forever. So let's just keep it as radicals where possible, just to keep it exact answers. So we're going to solve the following. We're going to move the 7 over, so we get x minus 1 squared equals 31. And I know some people would want to FOIL this out, but actually it's a perfect square right now. So if I square root both sides, I get that x minus 1 is equal to plus or minus the square root of 31. And then that x equals, if I add 1 to both sides, I'll get 1 plus or minus the square root of 31, which that represents two solutions. That represents 1 plus root of 31 and 1 subtract root 31. And if I wanted to get a decimal approximation, I can, but it says right here that it's saying to leave as exact solutions. So let's do the next one, B. Again, just algebra. Move the 2 over, we get 3x minus 5 squared equals 14. Square root, we get 3x minus 5 equals plus or minus the square root of 14. Add 5, so we get 3x equals 5 plus or minus the square root of 14. Divide by 3, we get 5 plus or minus the square root of 14 all over 3. Moving on. If I move the 10 over, I get x squared equals negative 9. If I square root that, I won't get a real solution there. So at this point, because I'm solving, I would say no solution. Let's do, again, the reason why it's no solution is there's nothing I can put in for x and square it, meaning multiply by itself to get a negative number, because the only way I can get a negative product is a negative times a positive or a positive times a negative. I can't find something that's going to be multiplied by itself that'll give me a negative. Okay, moving on to D, we're going to move the 12 over. We get negative 3x squared equals 16. Divide by negative 3, we get x squared equals 16 over negative 3. Again, we get to the point where we can't square root a negative number, so we will say no solution, NS. These two examples have solutions that are not real numbers. Since x squared cannot be negative, we say the equation has no real solutions. in fact, they have what's called imaginary solutions. So if you're ever curious, Google imaginary numbers, and we get into the complex number system, and they use the letter I for imaginary parts, and it's actually kind of neat. We really don't see imaginary numbers until, say, first year university if you take a linear algebra course. So it's interesting. Anyways, how could we solve x squared minus 2x minus 4? Well, we could try to factor it, and it doesn't factor by immediate inspection. So can we somehow make it undoable? Meaning undo the square. So the previous questions were in a form of a perfect square. If you look over here, they were all like over here, the 3x minus 5 and the x minus 1. They were what's called the perfect square trinomial. I think you've heard that term before. And that was when you completed the square. Remember that? So if we want to actually isolate a square, we do what's called completing the square to get it into that perfect square trinomial form. And then we can actually solve it like the previous questions. So forget about this equals 0. When we completed the square last unit, we had y equals 2x squared minus 12x plus 11. It was y equals that. So do you remember what you did to complete the square? So first off, we rewrote the first two terms and left a space. So 2x squared minus 12x, and then we left a space so that we can add stuff in there, right? But before we did any kind of completing of the square, we always had to factor out the coefficient of x squared. So we left the 2 out, and we factored that out. So we got x squared minus 6x, leave a space, plus 11. I'm actually going to leave more of a space after the equals 0, and you'll see in a second why. Okay, so everybody see what I just did? Again, the equals 0 is kind of like how we had the y equals in the last unit when we were completing the square. So, of course, the next thing is to determine the square of half the x unit. So what we did was we took half of the minus 6, which is minus 3. We squared it, so that was a plus 9. We didn't just add 9 here. We add 2 times 9 to the left-hand side, which means I need to subtract 18 to compensate it. What does that simplify to be? That simplifies to be 11 minus 18 is minus 7 equals 0. So, well, I guess I went a little ahead here, but anyways, add step 3 right after the first two terms, which I did, which was the 9, and subtract it to the right of the constant. Again, be careful of the coefficient. This step works because adding and subtracting the same terms undo each other. It balanced it, meaning the 2 times the 9 and the minus 18 didn't change the equation. So now, because this is a perfect square trinomial, I can actually get the perfect square and solve for x. So how did I do it in the previous question? I moved the 7 over. So 2x minus 3 squared equals 7. How did I go from there? I divided by 2. So x minus 3, the whole thing squared, equals 7 divided by 2. Then I square rooted, so I got x minus 3 equals plus or minus the square root of 7 over 2. And I got my final solution to be, I add 3 to both sides to get rid of the 3 on the left side. So it's going to be 3 plus or minus the square root of 7 over 2 as my final answer. And again, I could punch this in and get the decimal equivalent. Sometimes the answers are in exact values. Sometimes they're in decimal equivalents, or approximations, I should say. So you got to see what the question's actually asking. So let's try a few here. Complete this, solve by completing the square. So again, we move this so we have some space. So plus 4, and even leave some more space that equals 0. So there's not a coefficient I need to factor out. So I'm going to take half of minus 10, which is minus 5. I'm going to square it, which means I'm adding 25. I can't just do that, so I subtract 25. And this part represents this. So I need to combine plus 4 minus 25, which is minus 21, equals 0. And then I still got to solve. Remember, this is solved by completing the square. So I completed the square, not done yet now. I got to move the 21 over, so I get x minus 5, the whole thing squared equals 21. When I square root it, I get two answers. I get plus or minus the square root of 21. Then I have to move the 5 over last step. So 5 plus or minus the square root of 21. Again, if I were to punch this into my calculator, I would get 5 plus root 21 and 5 subtract root 21. And if I wanted to have, say, correct to, I don't know, say three decimals, let's do 4. I just punch it in my calculator. 5 plus the square root of 21. And I get approximately 9.5825. And the same thing with a minus is approximately 0.4174. So I'm just showing you both just in case the answer in the that you're looking at is a decimal rather than an exact value. Okay, so let's do B now. First step, we need to factor out the 3. So that means the middle term is a 4x. Leave a space so that we have room to add or subtract depending on what this is. So half of plus 4 is plus 2. If I square plus 2, that means I am adding 4 to it. But really, I'm not adding 4. I'm adding 12 to it. So then I got to subtract 12, which means I have a plus 4, and that's equal to 0. So let's move the 4 over to complete our solve. And to move it over, that would be now a minus 4. Then I have x plus 2, the whole thing squared, equals negative 4 over 3. Remembering back to those two questions that when I square rooted both sides, I cannot square root this part right here. So that means we have no real solutions. So we will answer it as saying no solutions. Okay, let's go back to C up here. So again, first step is factoring out the coefficient. Leave a space. Okay, so what's half of minus 2? It's minus 1 squared plus 1. I didn't just add 1 though. I added 3, which means I need to subtract 3. So then I get minus 4 when I combine. Now I need to finish it off. So how do I finish this off? I need to move the 4 over. So 3 bracket x minus 1 squared equals 4 when I move it over. Then I divide by 3. I get x minus 1, the whole thing squared, equals 4 over 3. Square root, I get x minus 1 equals plus or minus the square root of 4 over 3. And then x equals, if I add 1, I get 1 plus or minus the square root of 4 over 3. Now, I'm going to try to do the decimal equivalence here just so you can get some practice punching this in. So try this on your calculator just to make sure you know how to get this. So the first answer is 1 plus root 4 over 3. So 2.1547. And then the same thing, but a subtraction this time will give you negative 0.1547. Okay, let's move on to D. Minus 2, I factor out. I'm left with, and this is You got to watch now. You got to watch because this is now a plus 10, and if you're factoring out a minus, this is going to be a minus 5. Sorry, minus 5x plus 3, leave a space, equals 0. Now, if you were to look this up in some textbooks actually move the 3 over already to the other side, and then when they complete the square, they balance it from the right side. I kept our completing the square on the same side just so that it is consistent with how you learned it last unit. So anyways, negative 2, if I take half of minus 5, that would be minus 2.5. And if I square that, that would be plus 6.25. So really, I didn't add 6.25. I actually subtracted 12.5, which means I need to add 12.5. So that is plus 15.5. Now I need to complete the solving process. I completed the square process. I got to complete the solving process. So move the 15.5 over. So I get negative 15.5. Divide by negative 2. I get x minus 2.5. The whole thing squared is, what's 15.5 divided by 2? And it's a negative divided by a negative, so I'll get a positive. That is, let me see here. Oh, yes, 7.75. And then I square root that. I get x minus 2.5 equals plus or minus the square root of 7.75. So x equals 2.5 plus or minus the square root of 7.75. And again, you could get the decimal equivalents or leave it like that. Because this is already decimals, I'm going to actually find the equivalent here. 2.5 plus the square root of 7.75, 5.2838, and punch it in again. I get negative 0.2838.